So in the previous session, we talked about how to enable TCP communication on the Docker daemon, right? So that external tools can connect to the daemon from outside, correct? So doing so, we also said that, you know, this is a security concern because now anyone who has access to that particular port can talk to the daemon for creating, destroying, the containers, correct? So what we will do in today's session is, we will enable TLS communication, between the client and the daemon. Okay. So yesterday, if you remember, I asked you to go through, the videos on TLS communication, correct? Right, guys? Okay. So here
Yes.
you have your Docker CLI and then you have your Docker daemon. So earlier what we did, so we opened 2375 port. So that is the default TCP port without TLS. Okay. So this CLI will connect to the 2375 port. Okay. So which is opened on the daemon to run remote commands. Okay. So now what we will do is, see, this is an insecure communication because, so there is no, you know, so what do you say? TLS based communication. So the traffic is completely open. And now what we will do is we'll try to secure this communication. Okay. So when we say about securing the communication, so here we are going to, authenticate your client with the daemon. Okay. So we will now enable TLS communication. So that is, we will also change the port on which your daemon listens on. And also we will secure the communication using TLS certificates. Okay. So when we talk about TLS certificates, you have certificates for the client, you have certificates for the server. Okay. And these are signed by your certificate authority. Okay. Since we don't have a public CA, so what we will do is we will create our own CA. Okay. Our own private CA. Okay. So CA will have its own certificate and key. Okay. And here the thing is the certificate of the CA is signed by its own key. Okay, its own private key. So that's why it becomes self-signed certificate. Okay, so here CA will have its own self-signed certificates. Now this CA will sign both our client certificates and server certificates, saying that these certificates are now signed by our CA and these should be valid and trusted. Okay, got it, guys? Clear?
One basic question here, Vikram. When you say that we can become our own CA, so is it like the communication between, suppose you have a
See,
Docker
see, when
server?
I talk about becoming own CA, so it is just like, I am HashiCorp Corporation or I am the Linux Foundation. Okay.
Oh, okay.
Okay. So here I have my own certificate. Okay. So if I create my own certificates, let's say dummy certificate, no one is going to trust me. If this Linux and HashiCorp signs my certificate or issue my certificate saying that this person, qualified in HashiCorp certification, okay, and I am issuing a certificate along with my signature. Okay. Now this becomes a proper certificate signed by some known authority. Now anyone can, by looking at your certificate, understands that it is signed by some known authority and it should be trusted. Okay.
Okay. So it is a self-signed in the sense, so the vendor himself is issuing the.
You created your own organization. Okay. Like HashiCorp. Okay. Like GoDaddy, who issues the certificate.
Right.
Okay. DigiCert. Okay.
Yeah,
So
I
the
know
way
this.
we get a signed certificate is, okay, so usually, when we talk about a client certificate and a server certificate, so it will have, for authentication, so you will have a private key. You will call it as a public key. Okay. So that is where we, when we talk about SSH based authentication, right? Okay. Using keys, using public key encryption. So we'll have public and private key, correct? But when we talk about certificate, so we have both our private key, we have our public key in the form of a certificate. A certificate will have the public key. Okay. So the thing here is this certificate with the public key has to be signed by someone. Okay. Like your CA. Correct? Got it? Since the certificate we cannot issue it, what we are going to do is we are going to generate a CSR, certificate signing request. So that will have your public key information. See, private key you should not share it with everyone. So this CSR will have your public key, and then you share it with your CA. CA will sign it and it will give the certificate. Now you will have a certificate and a private key. Certificate will have the public key of you, but it is now signed by a trusted, organization. Okay. Similarly, you'll have, a certificate and a key for Docker client, certificate and key for Docker server. Both are certified by some CA. Okay. Got it? Clear, guys?
Yeah, a little bit about the port numbers while accessing these certificates. I mean, how is that some tag to some port numbers on each of the
Mm,
node?
No, it's not like that. So you should go through the videos which I shared.
Yes, I
It is
didn't.
not related to any port. It is related to the securing the communication.
Correct, correct. Yeah, but communication can happen on the port numbers as well, right?
That is the communication endpoint. But how do you encrypt the traffic? It is through certificates.
Okay.
So here, when you talk about a web server, right?
Mm-hmm.
When we talk to the web server, we usually use 443 to talk. So
Yes,
here in the daemon, we are saying we will talk to 2376.
correct.
Okay. So this is about, establishing a TLS communication. So we already said we will have two machines, EC2 instance. So one is running your daemon, that has your Docker daemon, and one having just your client, that is Docker CLA. So we will put our both, the certificate and key for the client in the client machine, certificate and key for the Docker daemon in the daemon machine. And then we will have some configuration changes. So that will enable, TLS communication between the client and the daemon. Okay. So let's see how
So there
to
will be two
achieve
certificates,
this.
one for client and one for.
Yes. So there will be two certificates, one for client and one for the daemon, one for the server. Okay. So we already included some information. I already included some information here. Okay. So the first thing what you have to do is just search for enable TLS Docker daemon. Okay. So we just want to, get that, particular link. Okay. So this is the link that is securing the Docker daemon. So securing Docker daemon can be done in two ways. One is through SSH. Okay, this is we don't use this. The another one is using TLS certificates. So this is what we are interested in. Okay. The first thing is, as we already discussed, so we will have, public key and private keys generated for the client and this, and the server as well. But these has to be signed by someone like CA, right? So first, what we have to do is we have to have a certificate and key, for the which one? For this CA. So first you need to create your own CA, but ideally CA will be, your trusted CAs like DigiCert and all. Okay. So they will issue your TLS certificates. So you should be sending a CSR request that is certificate signing request to these organizations or enterprises to get a certificate for you, which means you need to buy an SSL certificate. Okay, but we don't have, I mean, I don't want to spend some money, so I will create my own certificate. Okay, so how do I create a certificate? Own CA, sorry. So I should have a key first. Okay, and then from the key I will generate a certificate. Okay, so usually, when you see the term key in the file name, you assume that it is a private key. Anything without the key, you can take it as a certificate. Okay, so first, using OpenSSL. OpenSSL is a utility. Okay, so you can run these commands on the Docker host, I mean the daemon machine, to generate it. Okay, you can do in your local machine, you can do in Docker client machine, it doesn't matter. Okay, so here I will do it in daemon machine. So this is the command I have to run. Okay, so here I'm in the server machine, systemctl status Docker. You can see Docker is running here, engine is running. Okay, so what I'll do is probably I can make uh, a folder here and then cd into that folder. Okay, remember I'm doing it in the daemon machine. Okay, so let me cancel it. Let me run only this. Okay,
Hmm.
it copied everything. Let me run only this single command. So it will ask you to enter a passphrase. So I'm just giving admin123 just to, see why I'm asked to give a password for generating the key for the certificate authority is certificate authority can sign others certificate with its private key. If private key is not protected and anyone who has access to the private key of the CA, they can sign other certificates. Okay. That's the reason
It's
why it
some kind
is
of a
protected.
hacking, or you
It's
think
not
that?
hacking. Anyone who has access to this private key of the CA, they can sign other certificates. It's like someone who has got HashiCorp's access so that he can, sign anyone's certificate even without passing the examination. Okay, got it? Now what we are doing is here, we are trying to generate, see, usually what is the process is, first you will generate your public key and a private key. So these are not certificates yet, right? So private key is something you will protect yourself. So it can be both client and server. I'm not talking about so to which part these keys are belong to, like whether it can be server or it can be client. Okay, so you generate your public and private key locally in your machine, and then you generate a CSR, certificate signing request, that has the information about your public key. Okay, then you send this CSR, okay, to a certificate authority like GoDaddy or someone. They will analyze your CSR. They will verify your identity, whether you are, the actual owner of the website, your email, your address, everything. And then they will provide you something known as certificate, CRT, that can be in the format of PEM file. Okay. So this is the certificate, and you have your private key with you. This will give you a unique identity, either for client, either for server, either for a domain that you own. It can be anything. Got it? Clear, guys?
Yes, so just a small question here. So, giving the certificate, is a chargeable activity or it is a
Yes, it
free?
is a chargeable activity. That's the reason why we are not going for public CS. We are creating our own CA. Okay. Our own CA means CA has to have again its own certificate and its own private key, right?
Right.
But this certificate is not issued by anyone because it is a CA. Who will issue certificates to the CA? No one can issue, right?
Right.
Because it's a top CA. So this certificate that CA has, it is signed by itself, called self-signed certificate. Okay.
So every
But
company, every
this,
IT company can become a CA.
yes, every IT company can become its own CA, but it's not right. Every company has its own private CA that is offered by GoDaddy, DigiCert.
Right. Right.
They have their own, private CA infrastructure, which we internally call in our organization as PKI infrastructure. There will be a separate PKI team that will issue your certificates for the domains, for your applications, right? You request
Yeah.
to the internal PKI team.
Yeah.
Okay. So this is the usual process. Now, what we are doing with this command is we are just taking the input of our CA's private key and then we are generating directly the certificate for it. Okay. We are generating the self-signed certificate. So now see, the certificate has to be signed by the private key of the CA. It will ask for the password or passphrase every time you try to use the CA's key. Okay. So the country name of the CA, let me do IN. This is important. KN. And then, so I'm just filling out some information. Organization, organizational unit, let's say something like this. The common name of the CA. So the common name of the CA can be anything. Okay. So I'm just giving uh, okay, my website as the CA. Email address I'm just skipping. Okay. Now if you tell ls-l, you will see that ca.pem, this is the certificate and this is the key. Okay. So these belong to whom?
To the same company.
To the CA,
Yeah.
certificate authority. Okay. And who issued this certificate to the CA?
They have generated their own based on their
It is
ROC.
Self-signed.
self-signed certificate. Okay. But ideally, what you should do, you should generate your public key, private key, insert your public key into a CSR form, send that CSR form to CA. CA will sign it with its own private key and it will issue the certificate. Got it? So I
Yeah.
have clearly explained in the other videos which I shared. Now CA's part is done. So what is the other part? Now we need to generate certificates for the Docker daemon and as well as the Docker client. So first we are generating the using the same command we are generating for the server. So we are generating the server key. This is the private key. Okay.
So the
ls
naming convention,
-l.
the naming
Naming convention,
convention
it is up to you. Okay.
for CA also it is up to us, is it?
It is up to us. But when you're configuring in the configurations, you just give the proper path. That's it. Okay.
Okay.
Now, what I said is last time. So when you have a CA, okay, so you have to generate a CSR for your, what you say, for your certificate. Okay. So here, what I am trying to do is, so I have my private key generated for this server using this command, right? Now I want my certificate to be signed by a CA. So here I'm not generating my certificate, okay, using self-signed way. Here I'm generating a CSR. This CSR will be signed by the CA. So in the CSR, what I'm doing is I'm requesting for a certificate saying that I am this host. But what is this host? Okay, if you see, they might have used this host means it can be, the IP address. Okay. So what is the host? The host is the, any domain that you own, the IP address that you own. So what I'm doing is since I'm generating the certificate for this server, I'm saying common name means to whom this certificate has to be issued. I'm saying issue it to this particular IP address, which is the IP address of the server. Okay. Now, how you are generating that CSR? You're asking, you're inserting the subject related information. So always remember common name means it is the DNS name or the IP address. It can be anything. Okay. I'm generating the CSR form for the server. Okay. I generated the CSR form. So usually you take the CSR form, go to DigiCert or GoDaddy, upload it, pay some fee and get the certificate. But I have my own CA locally. So what I'm going to do is following the documentation. Okay.
Vikram, we create CSR using the public key of my own public key, right? As you said, right? But here we kept our private key.
Yeah. So this is the key that I have to insert.
So
I
that's
have to
the
put.
private key, right?
Sorry. Yeah,
So
that's
that's
the
not
private keys. Yeah, correct.
So CSR should be created by using public key
So
as
did
you.
I mention? Oh, I think it is the private key only. Next, we are going to sign the public key with the. No, see, this is the input we are giving.
Okay, that will extract
Okay. Yeah. So
like
this
from
will
private.
create the equivalent public key. Now you're going to see next, we're going to sign the public key with our CA. So it will internally have it.
Okay.
Okay.
Yeah.
See, and one more thing. So when you're talking about a subject, right? CN. Okay. So we just gave a single IP address. Okay. But sometimes we also need to provide alternate names to our domain. Okay. So sometimes your domain can be www.devopsmadeeasy.in, or sometimes people will ignore www and simply give devopsmadeeasy.in, right? Or sometimes they might use the DNS name, the IP address. That's the reason why, along with this host related information, so we should also give some extended, you know, we should also give, what do you say, the alternate names for your subject. So here I'm giving the same IP address as one DNS name, another IP address. One second, guys. Yeah, so this is the IP address, but usually you will put a domain name and then IP addresses. What all other IP addresses I can give? I can also give this IP address, right? Which one? The private IP address. Okay, just a second. Let me verify it again. Yeah, anyways, it's fine. Okay, I can give my the private IP address like this, or it can be the local host address as well. Okay, it can be anything. So I'm going to echo this, and then I have to include this. Okay, to use this extended key attributes using this. You don't have to know all these things. Okay, that is done. Now our CSR is ready. Okay, if you see ls-l, you will see server.csr, and then we have server key, but we don't have the certificate yet, right? Because we are going to use this command. This command says issue a certificate for 365 days, take the input of server CSR, okay, sign this certificate with CA's certificate and CA's key, and create server cert. Okay, that's it. Now, since we are using CA's private key again, you will be prompted to enter the passphrase. Now, if you see, we have server key and a server certificate. Now your CSR is no longer required. We can delete it. Okay. So they might have given the deletion part. It's not there. It's okay. Clear, guys? Any questions?
So generally, if it's like youtube.com, so this is the actual certificate that is present in the browser of our Chrome or something, right?
No. So this server CSR, server certificate and key, will be present on the server where YouTube is hosted.
Okay.
Okay.
Okay. Okay. The upcoming part which we will create, that will be present in the browser.
No, we don't put
But the
anything
CLI
in the
part,
browser.
I mean, the CLI, Docker CLI, we will create one more.
Yeah,
Yeah, that will be
correct.
present in the browser.
No, in the browser, we don't have anything. See here, we are using client as the Docker CLI. We are
Yes.
not using client as the browser in order to put some certificates on the browser. Okay.
Okay. No,
See,
I'm just,
our communication is between CLI and the daemon. So we don't
yeah.
have the browser involved here.
Yeah, here I'm sure I'm just asking in general if I want to connect
Mm.
to .com, so I don't generate CLI side, I mean user side certificate or
Users
CLI.
as certificates are actually automatically generated by your browsers.
Yeah, exactly. So that part will be present in the browser, right? Okay.
But we don't put anything in the browser. See,
Yeah, exactly.
when a certificate is created by known certificate authority, your browser, see, you have to, basically go through the video I gave. Okay. So if you see this docker.com, the certificate is valid. Okay. So who issued the certificate to this docker.com? It is Amazon. Okay.
Right.
Got it? So here, all these are automatically updated. So you don't have to do anything. Okay.
Okay.
And now we are done with the server certificates and the keys. So it's time, we generate the client certificate. Okay. So here, uh, we are running this command to generate the client. So
Sorry to
here
cut.
they have not used server key.pem, client.pem. Simply they have used key.pem to indicate basically it is a client key. Okay.
We need to generate it in client, right?
Anywhere. See, it can be anywhere. The reason why I'm generating it in the same machine is because I have access to CA information, right? Because I need to sign the CSR with the CA. Got it?
Oh,
It can be anywhere. If you have the CA information in the other machine as well, you can generate it other way. And now we have to generate the CSR. So ESR, see the client, I'm not giving any specific client related information like the IP address or something. The common name is simply client. That's it. So I've generated my own CSR. If you see, I have my own CSR now, client.csr, which has to be approved by, your CA. So I'm just, following the methods which are given in the documentation. So here, what I'm doing finally, I'm taking the CSR of the client and then getting it signed from the CA's public and private key so that they will give back my key. Okay. So here what I'm doing, I'm just entering the passphrase for the certificate for the CA's private key. Okay. Now if you see, I have the client key and a client certificate. Okay. And the CSR, the external file, CNF and all I can delete. Okay, I think they have given. Okay, if you see, they have given this command to delete the extra CSRs, all these files, etc. Okay, I'm just deleting all those. Now, if you look at the files, okay, we have CA's private key and certificate, server certificate and key, uh, client certificate and client key. Got it? Clear, guys? Okay. So now what I'll do, I'll now configure, these certificates both on the server and on the client side. Okay. So here they are saying these certificates uh, are world readable and writable. So they are asking us to just protect these certificates. Okay, that is fine. Okay. And if you see here, your Docker daemon should now use the certificates of the server. Okay, so certificate of the server, I'm providing it with TLS cert. The key of the server is provided using TLS key, and the host information is also now changed to 2375 to 2376. Okay, so this information I need to, basically give it to the, the server part. Okay, but we already, just saw this kind of, what do you say, the configuration of the daemon, that we can do it in daemon.json file, right? Guys, correct? Okay, so what I will do now is, since these certificates are, in home easy to use a search, okay, I don't want to put all the certificates here. I will just do mkdir -p. Okay, let's say var, um, something like this, var and certificates. Okay, I'll try to copy everything, okay, to var search. And if I ls-l var search, okay, you can see that all are available. Okay, because I don't want to put, in the EC2 user. That's okay. I'm not deleting them as of now. Okay. So we have all our certificates here in the var certs. And also they asked us to change the, what do you say, all the certificates, like the private keys, to have 400 as the permission. Okay, and the certificates to have 444 as a permission. Okay, so I have changed them successfully. Okay, and then it's time for the daemon to use these values. Yesterday we, if you remember, docker daemon configuration, if I search, so daemon configuration we can do it in etc docker daemon.json. And also I told you, if you go to docker reference t, and if I just go to the last, we have the entire daemon configuration file. Correct? Right, guys? Understood?
Yes, okay.
And also, if you have that config file, I can also verify whether that config file is, probably correct or not, using a command known as validate. Just a second. Somewhere it is there, or I think it is in the previous page. Let me go back. So if I have the configuration file, um, no, I can validate it actually. Or did I give it in the documentation by any chance? Docker D validate, it is there. Okay. So what I'm going to do is, so we have the daemon file example here, right? Okay. So that daemon file should be in etc. So let me also copy the contents of this, just for my reference for the naming conventions. And the daemon configuration will be etc docker and then daemon.json. Okay, so we already have the host information here. So this time we are changing the host to listen on 2376, because if you go, so once you have the certificates and all, you need to change the host to listen on 2376, and you should have TLS verify. Okay, and TLS tsert. Okay, so where exactly these are available? These four configurations. Okay, I'm just copying them, and then I'm just, you use them here. So you just use a comma at the end and try to paste all four parameters here. So TLS CA cert. Okay, so what is your cert? Okay, always remember, don't put comma at the last entry in this JSON. So where is this TLS certificate for the CA? So we have everything in var, right? Var certs. What is CA cert? What is its name? CA cert name is? Tell me, guys.
CA dot pin.
CA.pem. Okay, and then, so let me copy this, the basic path. Okay, I'm just putting it, what is TLS cert? So that is for the server. Okay, it is server cert. Okay, and the other one is now server key. Okay, clear? And TLS verify it is true. So let me just save this file. Now, once it is saved, I can also verify whether the Docker daemon will accept it or not. Okay, so Docker daemon -- validate -- config -file. I'm asking it to take the config file from this daemon.json. And now it says the configuration is okay. Okay, so we can now restart Docker service so that it will restart the daemon and take that. Okay, what should we do now? We should check the status. Okay, so we see that your daemon is running successfully. Okay, enable and it is active running. Okay, you can also do Docker PS. Now internally it is actually also listening on that Unix socket, right? So it is able to execute. But if I use a host with the client saying that you connect to probably 0.0.0. on the same machine 2376, right? Guys, if I ask this client tool to talk to the 2376 port on the same, see here what is the error it is now giving, right? Clear, guys? The same thing, if I go to the client and then do docker -host, so we're asking the client to connect to our what do you say, our server. On this is where the server is running, right? Now 2376 is the port, correct? Is it able to connect? The client is able to connect now? No, because client certificates are not provided to the server. The server is not validating the request. Okay, got it? So client also need to be configured. So how the client needs to be configured? So the client should now use TLS verify. Okay, so this is now enabling TLS communication between the client and the server, but you need to configure the client's certificates on the client machine. But we have everything in the server machine, right? Correct? How will I transfer them to the other machine? Through SCP, correct? Or by manual copy. So how do you do this using SCP? I don't have my private key to talk to the other machine. So I have to use username and password, right? To copy.
Yes. Yes.
Okay, so here on the client machine, what I'm doing is I'm setting the password for the EC2 user. Okay. One second. I'm setting the password for the sorry. Okay, I set the password for the EC2 user. And also I need to enable password-based authentication. Where is the SSH daemon configuration, so that this SSH daemon will allow password-based authentication. Where is password-based authentication? Here. So the password authentication is now set to no. I should use S. Okay. And then just save it. And then use systemctl restart SSHD, so that it will now also allow me. Okay. So here what I'll do is I'll go back to this server now. Okay. I will use SCP, what all files I wanted to copy. Okay. The first is I need to know the, you can see you should have which one? ca.pem, cert.pem, and key.pem. All three should be available on the client. I am on the server, so I'm copying ca.pem, key.pem, cert.pem, all for the client. Okay. On the client machine, I'm connecting to the EC2 user at the rate of client machine. What is the IP address of the client machine? This is the public IP. Private IP will also work. On the client machine, I'll simply move them to /home/EC2 user for now. Okay. It will ask for the password of the client machine. Just enter the password that you set for the EC2 user. Now I'll go back to the client, and if I check the home EC2 user, I have these files. Got it? Clear, guys? Now what I have to do is for the client to use all these certificates, client certificates, I need to copy them into a folder called .docker on the machine. Okay. So I need to just create this folder first. Okay. So I'm doing it as a root user, but make sure that you use as a normal user. Okay. So I created the Docker folder. Okay. And now I need to copy whatever files I just copied into that location, because so this docker, it is just a folder. So where the client can, take the information about the certificates related information. Okay. That's why I copied it. Now what I have to do is, so I have to now use Docker host, Docker TLS verify, all these things. Got it? Clear, guys? So now what I have to do is, when I'm talking to the daemon here, I'm giving this host information, but I should also pass this flag called TLS verify, so that I am including my TLS related information. So this is a client which is now talking to the server. Okay, it says error during connect, get TLS verify failed to verify certificate X509. Certificate is valid for
Change the IP address.
just a second. TLS verify fail. Not 34/2015.
Port number also should be given.
Uh, just a second, guys. Let me do one thing. Let me use this export command. Docker host is IP address of this. That is fine. If we have not included proper the IP address, it would fail. So I'm exporting these environment variables on the client machine first. And then if I do Docker PS, so there it says, TLS failed to verify X509 certificate. Certificate is valid for 172 dot something. Oh, so we did a mistake on the, okay, I now understood. So here, when we, when we requested for this server CSR, we requested with one IP address. Okay. So what I'll do is I'll again run this command. Okay. So where exactly? So inside this ls-l. Okay. So let me take backup of all these things first. Okay. So mkdir backup. I know what went wrong. And then copy all PEM files. Okay. Into that backup. Okay. It is just for my safety. So when I created a server certificate, right? Server certificate, and so here I'm generating the CSR again with some IP address. Now when I added the subject name alternatives, so I have given this DNS name. Okay, so here this DNS name is matching this. So this DNS, what I'll do is I'll try to give a different one. So I'll go to Docker, what do you say, the I'll take the public DNS, something like this. Okay, instead of just giving the IP address. Okay, I'll give the DNS name and then the other IP addresses. Okay, so this other IP addresses, instead of using this, 127.0.0.1, I will include the public IP address. So one is the private IP. What is the private IP? Okay, so this is the private IP. I think I did not change it properly. Okay, so private IP. Okay, I will give this. And then what is the other? This one. Okay. And then I'm generating the server certificate by assigning the CSR. Okay, CSR, we need to provide the passphrase for the CA key. Okay, so now what I did is I generated new the certificate for the server. I should also restart the daemon to use this new certificates. Okay, so there is, oh, sorry, it is Docker, right? Got it, guys? Clear what I'm trying to do?
So every time we need to provide the DNS, is it?
Okay, so
Which
now
you
I'm
are,
able to connect. Sorry, your question?
every time we need to provide the DNS, is it?
Yeah, so actually
Which
what
is
I
our
did is I just replaced the DNS. So I used IP here, but again I used it here. So these should be the alternate names. Okay. So this is your primary DNS, and these are all your secondary DNSs to whom you want to issue the certificate. Okay. Clear?
and these IP addresses are like the server private IP
Yeah,
and
server
client.
IP addresses.
Okay.
Okay.
Vikram, one doubt.
Yeah.
So the client side servers, I mean, certificate and key, and server side certificate and key are completely mutual to, mutual, separate to each other, right?
Separate to each other. Yes.
Okay. So we got an error because like we are sending a HTTP
So
request to the
no. So we got an error because
No,
so we
not
are
this
trying.
error. Before error. Earlier.
Yeah, because your Docker daemon is listening on HTTPS, but your client is sending a HTTP request. It is not including its certificates for the TLS communication.
Okay. And so this our end also should be HTTPS solely to send.
Yeah, correct.
Okay.
So that's how the trust is established and the traffic is encrypted with TLS. Okay. Now let's say someone got access to this port. Okay. Let's say. Got it. So what they will do, they'll download the client and they'll simply say, I'll use this as host. And they will try to simply do PS, but it will fail. In our case, it is successful. Okay, because we have copied all the certificates to .docker from where your client can take it. Okay. So what if that .docker is not there? Let me temporarily, rename it to something like Docker to something like this. Okay, so sorry, cannot create. Oh, sorry, I'm using mkdir. Okay, so let me rename it. Okay. Now when you do this command, so what will happen? So they won't have the certificates, right? Which you have. Got it? So they won't be able to talk to the daemon from a remote client. Clear? Guys, clear?
So every time this path should be same.
Yeah. So now I renamed it back to .docker because see, this .docker location is for the client. For the server, it is etc docker daemon.json, or you can take etc docker. So for client .docker. Now I renamed it to .docker. So okay. Oh, I think I just messed up that folder. Let me just move all these files into the Docker again. Okay, so now do Docker PS. So it will again work.
Vikram, what if, yeah, let's say this is a separate new client and I issued that command, I don't have certificates, I will not able to connect, right?
Sorry, can you repeat?
Sorry, I'm a new client, new EC2, and I issued TLS port on -H. I will not able to
Hmm.
the
Yeah, you won't be able
daemon.
to connect. In
Uh,
fact, if I run the same command from the same machine your Docker is running, right? Docker, same machine I'm trying to connect to 2376.
yes, yes.
Okay, so this also I won't be able to connect because this client is not configured with the client certificates because I configured the client certificates in the other machine.
Yeah. So what if I generate my own certificate and pay? I have to sign it from the CA, right?
CA, correct.
So uh, so on the daemon side, the CA has the information of the daemon related data, right? Because I'm telling like I will go to any CA, I will get my own private certificate and key. I can send. Can I use that? I mean, in
Yeah,
specific.
you can use that. So if CA is issuing a certificate, that's how you can use it.
Any CA would work, right? That's what I meant to say.
Yeah, any CA, but that has to be trusted. Okay, so here, a single CA is being used to trust both client and the server.
Yeah.
Okay. So ideally, if you have various websites, so those will be signed by different CAs. And how different CAs, your browser is able to trust is your browser has information about all that CAs information. Okay, so if I just have to, um, okay, if I go to this certificates managed by Google, private and uh, privacy and security. Okay, you can see here. So this browser is trusting all the certificates of the servers, so which are issued by DZCert, which is issued by Komodo, Microsoft, right? Okay, so trusted root certificates. It is also trusting the Amazon Sign certificates, DZCert, Global Sign, okay, GoDaddy, all this. Got it?
Okay.
So there are some CAs which are by default embedded into, what do you say, in your browser. So if a CA issued a certificates to your domain, okay, your browser will automatically trust it and it will give you the green symbol here. Got it?
Yes.
Any questions, guys?
And every time a new user comes, if they want to have a communication with our Docker host, right? So we will do all these steps for every user.
Yeah, correct. See here, server side, it's a one-time configuration. Okay. On the client side, you can take the, the certificate. It's a single client certificate, right? And you can use it in multiple devices. It is fine. You don't have to generate multiple client certificate for your multiple devices. A single client certificate will do. Got it?
So those certificates we need to share it with
Mm,
to their
correct.
devices.
Correct. See,
Yeah,
this
got it.
configuration is only required when you want to remote access your Docker daemon. Okay, so you don't have to configure it for all the machines. Like, see, developers will have their own machines, right? On their laptop, they'll have Docker daemon, Docker desktop, and all those things. But they don't require any remote access. This is only required when you have Jenkins master, trying to talk to the, daemon which is running outside of it.
Yeah, like a
Correct?
process, like a processors. It was.
Yeah. So if there is any remote communication involved, then it is better to, protect that communication using TLS communication. Okay.
Yeah.
That
Okay.
is not like you require every time.
Yeah, understood.
Okay. Any other questions?
Vikram, so this sort of encryption, this is for only for the transit protection, right? So that I mean the server doesn't verify that okay, this client only I should allow something like that, right? This is only for the transit encryption, right? Data
No.
in the
See,
middle.
your server is also trusting the client because server certificate and client certificate both are signed by a similar CA.
Okay.
Got it? See here, one more thing. So when we are actually configuring the communication, right? So why we are including this CA related information? Not this. Where is that? 1 second. So why we are including CA certificate information? When I say about server, it is only server certificate and server key, right?
Yes. Yes.
Why I'm including CA? Because I'm saying these certificates are signed by the CA. And then why I'm including CS certificate related information,
Client side as well.
on the client side as well, because client is also saying my certificate is signed by this person again, this CA.
Okay.
Okay. So here there is no public CA, which my daemon and client both get the certificate validated. That's why we are including the CA information.
Okay.
Okay. Otherwise, CA information, if it is publicly signed, okay, we don't require the CA information.
Okay. Okay. Got that.
Okay. So when we don't have the CA information, that becomes still HTTPS, but it becomes, insecure HTTPS. See, the traffic is encrypted, but you don't know to whom you're talking, whether you're talking to the intended recipient or not. Okay.
But that is also HTTP because like let's say my servers actually got from public Digicert, and I am the daemon. I will get it from the Google,
Hmm.
my certificates. Now
Hmm.
I not include CA information both from both ends.
Correct.
Then if I
Because device is trusting your certificate. Okay, see, Chrome is a tool. Okay. So when you're loading a URL, let's say docs.docker.com, so your Chrome is verifying who gave the certificate to this docs.docker.com. Okay.
yeah Digicert
Who
yeah
gave
Amazon
DigiCert gave. Okay, so DigiCert, how it gave, it signed with its own private key,
yeah
right? Now, so this becomes, you know, it is just like an unknown combination for me
yes
because private key is not known to me. Okay, I don't know whose private key is this. First of all, I don't have access. I know that it is signed by GoDaddy, so GoDaddy might have used its own private key. So how do I debug this complete data? Only if I have GoDaddy's public key,
yes
correct? Where is GoDaddy's public key? In the
In
browser.
the
browser
browser.
So now browser knows whether it is signed by a GoDaddy or not, right? Let's say I own this domain. I okay. I will sign it with my own private key saying that I certified it. But will my private key be in the browser?
no
Public key be in the browser? No. Then this means even though it is having a certificate for the domain, it is signed by an unknown private key, which becomes, even though if it is HTTPS, it becomes an insecure HTTPS, which means this certificate is signed by someone just like a hacker who is trying to do man in the middle attack. It can be anything.
okay
Okay.
okay
See, the browser is the client, so it has the public key, so it is trusting it. So what about the Docker client? It is not a browser, right?
yeah, exactly
So it has to know who signed it. That's why we are manually providing the private key. Sorry, the certificate.
okay in the case of CLI, if I got it signed with Digicert, uh do I get on the client if I want to configure on the client end, how do I do that part?
Sorry, can you come again?
So I'm doing on the command line, okay, nothing to browser. So my daemon is actually got the CA from the Digicert.
Correct.
Now on the client end, I should do my configuration. So from whom I will get I will take it from the Digicert only directly.
You take it from the DigiCert only.
Okay. Okay. How do I have to request them to give your CA.pem?
No, no. CA information, it's only required if it is, you know, what do you say? If it is a cell sign certificate. Otherwise, it will be trusted automatically.
Okay.
See,
So we,
certificate anyways, you will get it. If you ask, you will get it. Okay, but like your browsers trust some of the public CAs, your systems also have the embedded certificates of all the public CAs. Okay,
Okay.
so they will be trusted.
Okay.
But will they make public? I mean, CA will make all keys public. I mean, open. Then hackers can also use the public key, publicly available keys, right?
But private key is not there, right, with them to sign the certificate.
Okay.
See,
So you
why
mean
they
to say
gave the
that,
public certificates in the browser. Even if I have CS public key, what will I do if I don't have the private key?
right? So my understanding in one statement or in one line is the public key and private key have to match. Then only the communication will
Yeah,
start.
it should match, yes.
So some kind of a alignment has to happen.
Yeah.
Okay. Thank you.
And we can also public key in client, right?
Public key in?
Client, Docker client,
Yeah, correct.
like public certificate.
Yes.
Oh.
So even if you miss a single certificate now, see, I am in the client side, okay? So if I do ls hyphen, okay, so I have CS key here. So what I'll do is, I'll take the Docker and then ca.pem file. So what I'll do is, I'll say ca2.pem. Okay. And then if I try to reach this, you can see here, it will say that key is not found. Okay. See, it needs. That's why it is given in the documentation as well. Okay, so by default, this is your client, right? What configuration is this? No, this is for the Daemon. Here. Okay, so if you want to secure a client connections by default, you can move these files to the Docker home, the .docker, and then you need to ask Docker client to talk to the daemon using the port that you mentioned, and also you need to set TLS verify to false. Okay. If you don't want to have complete two-way authentication, you can run Docker in various other modes. I've not tried this, but you can try other modes as well. But that is the basics of TLS, protecting your daemon with TLS to secure the communication between the client and the server. Okay.